This is lesson 1.5 on parallel lines cut by a transversal. So for this lesson, we're going to start by defining what parallel lines are and what a transversal is. Now, parallel lines, here I have a picture drawn of two parallel lines. This little symbol here indicates that the lines are parallel. And so it can have just like one set of arrows. I'm going to flip the page to show you. If they have another set that are parallel, they might use two arrows. So if you have a bunch of parallel lines on the same page, they will use the different number of arrows to show which lines are actually parallel to each other. So you could have three sets of those arrows, but that's really what it means, is this line is parallel to this line. Now, what does parallel mean? Well, parallel lines, they are equidistant. So if I were to measure like the distance from here to here from here to here at this end, that distance is going to be the same, and that distance is going to be the same throughout. Now remember, when you measure distance, you always measure it perpendicular. So we would never measure distance with the slanted line, but the straight distance at a 90 degrees is the same all the way across. So the first thing I would say for parallel lines, they are lines that are equidistant. So they're equidistant. Made a little stray mark on my paper there. All right. They are also, they have the same steepness. Lines that have the same steepness. And if you took Math 2 with me, the algebra class, we described that as slope, the steepness. Like we'd say these lines each have a slope of 0, so they have the same steepness. So they would have the same numeric value for their slope, for their rise over run. And then the symbol we use for parallel, instead of having to write out the word parallel, if you just draw two vertical lines next to each other, that is the symbol for parallel. Now, a transversal is a line that crosses two parallel lines. A line that crosses parallel lines. So here we have a transversal here crossing these two lines. Now, when this happens, a lot of times you will create acute and obtuse angles. Remember, acute is an angle that's less than 90, and obtuse is an angle that is greater than 90. Now, it is possible to create 90 degrees if it's perpendicular, right? But for this case, since it is a slanted line, we're going to get a set of angles that are acute, and we're going to get sets of angles that are obtuse. And we're going to go ahead and label these angle 1, angle 2, 3, 4, 5, 6, 7, and 8. If we look at angle 1 in this picture, we can say that that is an acute angle. Angle 2, clearly bigger than 90, so that is going to be obtuse. Angle 3 is also obtuse. And angle 4 is acute. Come down to angle 5, that is also acute. Angle 6 is obtuse. Angle 7 is also obtuse. And angle 8 is acute. Now, why do we label all these out like this? Well, when you have two parallel lines that are cut by transversal, and I want to point out, The lines have to be parallel for what I'm going to say next to be true. If the lines are parallel and you have a transversal, all the acute angles are equal to each other. So angle 1 is equal to angle 4, which is equal to angle 5, which is equal to angle 8. So all the acute angles have the same measure, meaning they're the same size. So if one of them was 30 degrees, they're all 30 degrees. Now, angle 2 is equal to angle 3, which is equal to angle 6, which is equal to angle 7. And these are all the obtuse angles. So all the obtuse angles have, well, I wrote 2 instead of the, let me fix that, have the same measure, and all the obtuse angles have the same measure. Now, one other thing. Any acute angle plus any obtuse angle equals 180 degrees. So, any acute plus any obtuse equals 180 degrees. And we will use this idea to set up equations. Now, in a traditional geometry class, they will give certain sets of angles names, like different pairs of angles and how they're located. I'm going to go over that information just because I feel like it's something we should cover since it's in a traditional geometry class. But the reality is, all of those things I'm about to go over are based off this idea that all 4 acute angles are going to be equal to each other, and all 4 obtuse angles are going to be equal to each other, and you can choose any acute with any obtuse. These two would equal 180. We know that because they're on the same line. Guess what? These equal 180, and these equal 180, 1 and 6 and 1 and 7. Right? If I take 2 and pair it with any acute, 1 and 2, 2 and 4, 2 and 5, 2 and 8, those would all equal 180. And so the things we're going to go over, like I said, is in a traditional book, but I don't know that we necessarily have to memorize this, because the principles we're going to use can simply be used by the information I just shared here. But we'll go and talk about how a traditional geometry class will discuss these angles. Okay, I want to define a few things. When I talk about interior, when I use the term interior, when you have 2 parallel lines cut by a transversal, interior means the space between the parallel lines. And exterior would be the space on the outside of the 2 parallel lines. And then when we have a diagonal here, I'm going to just write alternate. Alternate sides. So when I say alternate sides, I'm saying that they're on opposite sides of the transversal. So we're going to first talk about, and go and pause the video to write all this down, and then and feel free to just kind of copy all of this information down. Pause it, get it all copied down, and then I'll talk about it. All right, so hopefully you have all this stuff written out. I want to talk about corresponding angles first. Corresponding angles have the same relative position at each intersection. For example, angle 1 is at the top left. If I go to this intersection, so is angle 5. They're both top left. So angle 1 and angle 5 are corresponding angles, and they're equal. But we already know that because they're both acute. Angle 2 and angle 6 are top right angles, so they are corresponding because they're both the top right of the intersection. They're both obtuse in this case, which means they're equal to each other. So we already know that they're equal. 3 and 7 are bottom left. 4 and 8 are bottom right. So once again, they're corresponding, and they are equal. 3 and 7 are both acute, so they're equal to each other. Obtuse. 3 and 7 are both obtuse. 4 and 8 are both acute. So this principle of them being equal to each other, we already know because they're both acute and both obtuse, those pairs. Now, we're going to look at the pairs of alternate interior. Alternate means they're on alternate sides of this transversal, and they are an interior inside the parallel lines. So 3 and 6 are considered alternate. They're both obtuse, so we know they're equal to each other. And 4 and 5 are also alternate interior because they're on alternate sides of the transversal, and they're interior to the parallel lines. And 4 and 5 are both acute, so we know they are equal to each other. Alternate exterior angles. Well, 1 and 8 are on alternate sides of this transversal, and they're outside the interior, right? They're in the exterior. 1 and 8 are also both acute, so we know they're equal to each other. 2 and 7 are also on alternate sides of the transversal, and they're exterior to the parallel lines. They're both also obtuse, so they're equal to each other. And the last is same side. Now, the last thing I talked about on this page was that any acute plus any obtuse equals 180. Well, this just looks at a very specific pair of those, which is 3 and 5. So same side or consecutive interior. So these are on the same side of the transversal, and they're in the interior, so 3 and 5. And this is obtuse, this is acute, which means if I add them, they're equal to 180. They're supplementary. Same thing with 4 and 6. This is acute, this is obtuse, so they add up to 180. And once again, they are on the same side of the transversal, and they're interior to the parallel lines. So those are the basic names. I'm not going to quiz you over these. I'm not going to ask you to remember these. I'm just saying, hey, this is how a lot of textbooks would approach this. But I think it's simpler just to say, hey, if they are acute, all the angles that are acute, they're going to be the same size. And all the angles that are obtuse are going to be the same size as long as the lines are parallel. And you can take any acute of these and any obtuse of these and add them together and get 180. So we're going to use that idea on this set of problems at the bottom. This angle is obviously obtuse, it's 123 degrees. This angle is acute, we can see it's less than 90. Well, if this is obtuse and this is acute, what do we know about these two angles? Well, they must add to 180 degrees. And to solve that, we'll just flip the 123 to the other side. So 180 minus 123. This is a war. Positives win. 57 positives left over. So we now know that this angle is 57 degrees. This one's pretty simple, so actually I want to go ahead and change this a little bit. I'm going to change the question mark, and I'm going to put the question mark here. So we're just going to change it a little bit because that looks pretty much exactly the same as that one. This is obtuse, this is acute. I could have used this one, I could have used this one. Any of the acute angles paired with this obtuse, 125, plus the question mark, that acute angle, would be equal to 180. We'll do the flipping, 180 minus 125. That is going to mean that this angle is 55 degrees. It also means that all the acute angles, this one, this one, this one, and this one, they're all 55 degrees. So once you know one of the angles, you know all of that same type of angle. If this is 125, then so is this obtuse, and this obtuse, and this obtuse. So it really makes it pretty easy. Let's go ahead and flip the page. Now we're going to make it a little more challenging because we're going to have some algebraic expressions. What do we know about these two angles? Well, this is a vertical angle, right? Because they're across from each other. So I actually I'm not a big fan of that. I think I'm going to change this 23x plus 6. Let's cross it out. Let's put it right there. I think that's a better spot for it. Now, these are the alternate interior angles that we talked about, but I don't need to know that. I just know that this is clearly bigger than 90 degrees. This is clearly bigger than 90 degrees. They are parallel lines. That's what this indicates. So I know that these obtuse angles are equal to each other. So the 24x plus 1 should equal the 23x plus 6. And now we just go ahead and solve the problem. So our first step is flipping. We want to make sure all the x terms are on one side and all the numbers without x are on the other. So I'm going to leave the 24x here, and I'm going to flip the 23x. When we flip a term, it changes sign, so it becomes negative 23x. And we'll take the 1, we'll flip it to this side, it becomes a negative 1. And we still have the plus 6 here. Here we have a war, that's just x. Here we have a war, that's just 5. That is the answer. So x equals 5. Now how do I know if that's correct? Well, I can very simply plug these in and show that this gives me the same angle measure. Remember, we know it's greater than 90. It's between 90 and 180. So when I take 24x and I plug 5 in for x plus 1, I should be able to verify what that answer is. I'm going to grab my calculator here. And so I have 24, find a good spot for the calculator, that's better. 24 times 5 plus 1. 24 times 5 plus 1 is 121 degrees. Well, what if we tried it with the 23x plus 6, but in place of x, I'm putting a 5. So we're checking the other angle. So 23 times 5 plus 6 is also 121 degrees. So I have verified that, yes, these indeed are the same angle measure, 121. So when you set them equal to each other and solve, you find the value of x that makes that true. Let's go to to number 4. So here I have these set of angles. These would be alternate, because they're on alternate sides of the transversal, and they're exterior to the parallel line. So these are alternate exteriors. But once again, this is obtuse, this is obtuse. I just set them equal to each other. 25x minus 5 equals 24x. I'm going to do the same thing, the flipping. I'm going to put the x's on the same side. So this 24x flips to a negative 24x. This negative 5 flips to a positive 5. This is a war that leaves one positive left over. So we get actually the same answer as the previous problem. We get x equals 25. Now to check our answer, we'll plug the 5 in. So 25 times 5 minus 5, that's 125 minus 5, which is 120. So this angle is 120 degrees. We'll do the same thing with this expression, 24 times 5. That actually is 120 degrees, same as that one. So we have verified that, yes, this x equals 5 is true. If I look at these angles, these are corresponding. And these actually are, once again, obtuse. And it looks like these examples did all obtuse. I don't know why, but none were acute. But it doesn't really matter. If they were both acute, it wouldn't change the process. If they're both acute or obtuse, if they're both obtuse, they're going to be equal to each other. So I'm going to actually put the 21x minus 6 on the left side and the 19x plus 6. You can choose which order to do this in. I tend to find the number in front of x that's bigger, I set that on the left side. It helps avoid negatives. So 21x, flip the 19x, it becomes negative 19x. Flip the negative 6, it becomes a positive 6. So you wind up with 6 plus 6. Do the subtraction here, that's 3x. combine, like we're going to combine these. This is an alliance, so you get 12. We'll then, oh, I'm sorry, I made a math mistake. 21 minus 19 is 2, not 3. And then we will divide both sides by 2. We wind up with x equals 6. The thing I like about these problems is you don't have to wonder if your answer is right. You can just plug the 6 back into each of these expressions, and you should get the same value if your answer is right. So 19 times 6 plus 6, if you put that in a calculator, you'll get 120 degrees. So you get 114 plus 6, which is 120. If you use the bottom equation, 21 times 6 minus 6, you wind up with 126 minus 6, which is 120 degrees. So you do get that same angle measure for each one. All right, we're going to do one more, and then we're going to end part 1 of this video. For these are alternate interior angles. So they're on alternate sides of the transversal, and they're interior to the parallel lines. But once again, we can look, they're the same type of angle. One obtuse and another obtuse. They're both obtuse. So I'm going to take the 21x minus 6 and set it equal to 20x. Once again, I chose to put the bigger x term the biggest x term on the left side. This will help avoid negatives. So we have 21x. We're going to flip the 20x to make it a negative 20x. And we're going to flip the negative 6 to this side to make it 6. So you actually wind up with x equals 6 as your answer. And then we can do the same thing. If I take 20 and times 6, I get 120 degrees. If I take 21 times 6 minus 6, I get 126 minus 6, which is 120 degrees. So you can verify that that answer is correct. All right, so that concludes part 1. Please continue on to part 2 of this video.